All right, let's get started. So it's the first lesson that I'm seeing you guys this week. So we'll start with our weekly little check-in and have a little video to build those relationships. Cool. So I'll pick someone randomly out of my jar. We're thinking about breakfast, lunch, and dinner. Which was the best, which is the worst. Person sharing is going to be Ruben today.
Oh.
Ruben, how would you rank the meals?
Mine.
Yes.
Dinner is usually the best.
Mm-hmm.
Sometimes, on occasion, lunch can compete.
Depending on if it's a good lunch.
Yeah.
And then I'm guessing from that you're putting breakfast as your last.
Yeah.
Yeah, that's fair. Like a lot of people that I've talked to when I did this question in class, I've put breakfast last. And it's usually a combination of things like I don't eat breakfast, or I eat the same thing every day for breakfast, or it's always kind of like a rush meal. Just curious, did anyone not put dinner as their first choice? What'd you put, Charlotte? I think you told me.
Yeah,
Breakfast, that's usually the only meal you get a chance to eat. Hunter?
Lunch.
Lunch is your favorite meal.
Yeah.
Why is lunch your favorite?
I just eat lunch during the day.
Yeah.
I don't know,
Lunch is your favorite?
during the day.
Yeah. To be fair, I can see like how dinner might not be everyone's first choice because it's like at the end of the day kind of thing,
Yeah.
just kind of winding down. Whereas lunch is like a social kind of thing. You go out for lunch.
Yeah,
Unless lunch is not
What? And to be fair, dessert really only comes with dinner because you don't really have to serve lunch. Sometimes for lunch you get a but yeah.
For some reason, lunch for me feels like a chore.
Chore?
Like, oh, do I really have to?
Yeah. What was I gonna say? I normally didn't eat dessert. It wasn't like I would like dessert would be a special occasion thing.
Yeah.
It wouldn't be after every meal. But then I moved into the halls, and in the halls they always gave us dessert, and then I got into the habit of eating dessert, and I really am not happy about that because I do not need that extra food and sugar. So yeah, I was not raised eating dessert most days. Cool. All right, micro goal for this week. The person sharing their micro goal is going to be Emma.
Oh.
What's your goal for this week?
To finish my photography work.
Finish your photography work. It sounds like it's quite a busy week for you guys. I've heard there's health assessment this week.
I don't know. I don't know.
You don't do health. Is there a photography assessment due this week as well?
Not a photography assessment, but
Yeah.
just like little bits.
Okay. Cool. A little like checkpoint. So it's not too much pressure. Make sure you guys are prioritizing your work. I'm really happy if you want to put chemistry on the back burner because you have internals due this week and next week because it is getting to the towards that end of term. And we won't assess this internal until next term anyway. So I don't mind if I don't see a lot of chemistry work because I'm mindful of that. All right, anything that anyone wants to share? We're all good? All right, cool. Let's talk about our learning journey then. So last week was kind of a weirdish week because we did a little bit on Lewis structures, and then I decided to suddenly change gear, you guys, to make sure I can get paperwork done when I need it done. So we are moving on to qualitative analysis. It's not a bad thing, it's not a bad time for us to move on to it because we have been talking about ionic solids, and so this is a nice little refresher on ionic solids. So, yeah, do keep that in mind. Today's learning intention, I saw what you guys were working on, and you guys were starting to do those precipitation reactions, but you were struggling a little bit. So what I'll do for today's lesson is kind of refresh how do we predict precipitation reactions, and also writing those ionic formulas. The learning intention is also on the side whiteboard, so don't freak out as I swap things around. It's still there. Cool. All right, and then the last thing is our weekly fakatoki before we start diving into our lesson. So we have kote mori, mia huna ki te moana. So the life force is hidden in the sea. Powerful aspects of life are hidden in plain sight. I really think this is a good one for you guys this week because we are talking about water and we are talking about the life force of water, and we're talking about, one of the things we need to do to care for our water is to figure out what's in it to make sure it is healthy and that it can sustain us and sustain the environment. So I like that whole life force is hidden in the sea. In this case, it's going to be water. I was also thinking about it today because I was watching the news and they were talking about climate change and how we take things for granted, especially with our environment and how much the earth provides us. And, you know, it is in plain sight. We interact with the earth every day, obviously. And it's very powerful and affects our lives. And they were talking about how we need to reduce our carbon emissions very drastically, very quickly. Otherwise, our earth is going to be too hot and it's going to drastically affect our lives. Cool. All right. So let's talk about what we're doing for today's lesson. So I'll do some notes at the beginning to talk about predicting precipitation reactions. Then I thought it would be good for us to do a practical. We haven't had a chance to really do that. I think I should make practicals orange, eh? Give it a different color because we actually don't have a color for different. Precipitation reactions. I have all the equipment set up. And then lastly, we will look at some slide plan pages. We'll look at some slide plan pages just to practice a little more material. Cool. All right. Yay. Learning. All right. Yes, natural chemistry. Okay. All right, gentlemen in the corner. We ready? Okay. For our success criteria, we're looking at number 4, and that's identifying the possible ionic compounds that can form when we mix two solutions together, and we'll see that with that side cut page you guys started on. And that's basically what we are doing for this assessment. You're going to be taking 2 different bottles, adding a few drops into a test tube, and looking to see a precipitate form. So you need to be able to know what 2 potential options you have, and then how to go, this one's the precipitate, this one isn't the precipitate. Cool? All right. So, what I will do today is the predicting precipitation reactions on page 43. Does anyone not have internal side pad? Those are all my externals.
Yes.
Who has not been given an internal side pad yet? Because they were absent today, I passed these bad boys out. Bad boys. Anybody else with the internal side pad? Oh, I got Sharpies. You got Sharpies. Anybody else? Side pad? The one. What do you mean just? All right. Cool. Oh, I was going to give you guys a table of ions. Forgot to do that.
What page is this?
43. I'll print you one out and I'll run back and bring it in once you guys are doing some book work. All right. Cool. And I feel like I want, what markers do I want today? I think I'll do these. All right. Cool. So, I'm going to work through some examples, and then you guys can let me know if you need some more. So we are thinking about page 43, predicting precipitation reactions. what I want to do is revise some of how we figure out how to cross the two things. And then I'll also revise a little bit on the formulas as well. So the first thing that I see here is that I have sodium hydroxide and I have copper sulfate. And they've given me both the formula and the word. All right, so I'm just going to make a note that that's what we're mixing together onto my piece of paper before I move the SciPad away. So we have sodium hydroxide, which is NaOH, and we have copper sulfate, which is CuSO4. All right, I'm going to move the SciPad away so that way we can just focus on how we take this information. So, one of the ways that I think is useful to help you kind of organize your thought process with this is to just create a little kind of like cross-section diagram, kind of like a Punnett square. And what I'm going to do is kind of show you guys how things get written down. So, I will do warm colors for the cations and cool colors for the anions because I like to color code. All right, so the first thing I have is sodium. And that is my cation, that's the Na+. And the second thing I then have is my hydroxide. So I'm putting my, and that's OH minus. I'll print you guys a table of ions to help you kind of memorize your names, but do keep in mind you won't be allowed that on the assessment. Sorry, this is level 2. All right, what I'll write on this side is my second solution, which is copper, Cu2+, and my other component is the sulfate. Which is SO4 2-. Now, for those that are typing their notes on computers, do keep in mind that the subscript and superscript are really important. So you will need to show that when you're typing. So you might need to tinker around on Google Docs and stuff to get that annotation. It's part of the chemistry language, so do keep that in mind. All right. So what I need to do then is think about the products. So the products are what I'm going to be writing inside the little tables. But there's some things I need to keep in mind when I do that. It's just kind of like a Punnett square when I'm pulling things down and across. So in this case, sodium and copper. These are both cations, and when I do an ionic compound, I need a cation and an anion. So in this box here, I'm just going to do an X because there's not going to be an ionic compound form there because it's 2 positive charges. Cool? The other thing is I notice I have a negative sulfate and a negative hydroxide, so both of those can get canceled out because that's not going to form my ionic compound. Are you okay with how I've done that so far? All right, so now let's write down what we have. Now, to start with, I am just going to write down the name via word and not do any formulas. So I have copper and I have hydroxide as one of my products. Are we okay with that so far? So you see how I basically took the cation from one and I took the anion from the other to make my new compound. All right, the next one then, that's my sodium and then my sulfate. Remember the cation always goes first. Are we good with that so far? So that's how I decide what's the products. So these here, that's a reactant. That's a reactant. And then inside the boxes are my products. And remember, when we are talking about equations, you have, reactants, arrow, products. Are we good so far? All right. So let me point some things out to you guys, so that way you can think about the assessment and what is required. One of the things you need to do for the assessment is identify precipitates, and that is an achieved requirement. So you need to be able to do that in order to pass. Now let me grab my little flow charts. So on the assessment, remember, we are going to give you the solubility rules, and from there we can figure out, okay, which one is the precipitate. So when I see sodium sulfate, I'm looking at these list of rules, and I'm trying to see what could sodium sulfate be. Now, first thing, I see that sodium is in group 1 of my periodic table, and I see that all group 1 compounds are soluble. So most likely, that will be soluble. But we should go through the rest of the list and double check to see if there's some exception that I might have missed. So ammonium, there's no ammonium in either of those. Sulfates, well, we did say it's sodium sulfate, so it says most sulfates are soluble except calcium, barium, and lead. Well, I have sodium sulfate, so that's not one of the exceptions. Halides are all soluble except those with with silver and lead. I don't have a halide. A halide is in group 17, so the halogens. All carbonates, I don't have a carbonate in that example. All oxides, hydroxides, we don't have any of those in that example. All sulfides, we don't have that one in that example. So I know that this one here is going to be soluble. Are we good so far? All right. So I want to now check the copper hydroxide. So let's look at the list. I'm looking for the word hydroxide. I'm looking for anything that says copper to help me identify if there's a solubility rule. So I see hydroxides are here, and it says that all hydroxides are insoluble except if I have something from group 1 and except if I have an ammonium ion. So copper, is it in group 1? No. So that tells me that it is going to be insoluble. So that will be my precipitate. Are we good with that so far? All right. So let me add an extra note. I might get some other markers that are a little bit thinner when I write this note. And this is stuff to do with the assessment. So I should have used red earlier because now I'm going to ruin my color code system. All right. So achieved requirement. I'll write in red, requirement. I'll do merit requirements in blue and excellence requirements in green, so that way you guys can very easily see what is required for each level. So achieved requirement is identifying the precipitate. And I'm just going to abbreviate it as PPT. So that is something you need to do in order to pass, so you need to be able to use those solubility rules. When you identify the precipitate, it doesn't matter if you have it in the formula form or if you have it in the word form. So I would suggest if you want to give yourself a backup option to make sure that you can definitely pass, you should write down the word and the formula. So if you make a mistake on the formula, I can still pass you if you have copper hydroxide written down. Does that make sense? And we'll do lots of examples, and I will point that out to you multiple times. Are you okay with that so far? All right. Cool. Shall I keep going? Okay. The next thing we need to do then is our formulas. Oh, should I move it over here so you can still see that? All right. So as I said, you will not be given a table of ions like you got in level 1 science. So you do need to have memorized the different ions and how you translate the name across. Here's some good news though. The good news is on the resource sheet, we give you the list of ions and all their charges. So you don't need to worry about memorizing the ions and their charges because they are on the resource sheet. I will not provide for you, though, that this OH minus is hydroxide. You need to know that. And that this NO3 minus is a nitrate. So I'm not giving you guys that information. I'll print out a sheet just to help you guys memorize it. I just forgot to do that earlier. But the good news is these things are here. So you will have this information so you don't have to worry about memorizing those charges and the formulas. Are we good so far? All right. The other lovely little hint that I have for you guys is when you're doing the practical assessment, please look at the bottles. Because the bottles not only have the formula, they also have the name. So if you forget what SO4 is, you can look at the bottles that have been provided for you guys, and you can see the word sulfate. And that can help you ring a bell. Okay, so even though it's not going to be on the resource sheet, there are plenty of ways you can indirectly find it. Now, when it comes to these bottles, you see that there's a certain things that will be given to you, like barium nitrate, silver nitrate, litmus, sodium hydroxide. So we'll give you some of them. We won't give you all of them. Obviously, you're going to have an unknown solution, so you're not going to know what's in there. You use the flow chart to figure it out. All right? But there is some things to help you get started with figuring out the names and the ions, even though I don't give you a full table. Are we good with that so far? All right. So some refresher when it comes to the ionic compounds is we need to keep in mind that for ionic compounds, this charge needs to balance to 0. So I need to make sure that whatever I have positive charge from the cations, I also have from the negative charge in the anions. Does this ring a bell, hopefully? No, sort of. All right. So do you see how sodium is a positive 1? Yep. And sulfate is a negative 2. So if I currently add them together and I don't change anything with the formula ratios, my overall charge for that ionic compound will be negative 1. Ionic compounds need to be neutral. They need to have no charge. So what I need to do is I need some more positive charge to balance for that negative charge. Yeah? In this case, since sodium is a positive 1, if I have 2 sodiums, that would give me positive 2. So we would go Na2SO4. And that is my ionic formula for that one. Does this ring a bell? Do I need to draw and show any more?
Yeah, it rings a bell.
Rings a bell?
Yeah.
I'm just talking about the ionic formulas. We'll do balancing equations later. So the good news is if you're only aiming for achieved, you don't need to do any equations. Yes. All you need to do for achieved is tell me what the precipitate is. And you don't even need to give me the formula. You can give me the written name of that ionic compound and I can still pass you on that. So it is worthwhile to write both of them down. So if you make a mistake on the formula, I can still pass you on the word. Does that make sense to everybody?
Yeah.
Shall I repeat that one more time? You guys got that? Got it? All right. Shall I do copper hydroxide? All right. So copper I see is a positive 2. Hydroxide is a negative 1. So is it currently balanced?
It's not.
It's not. What do I need more of? Negative or positive charge? Negative. So how many hydroxides will I need to balance positive 2? 2. All right. Cu. OH. 2. Do I have that right? That looks funny, doesn't it? No, it goes behind. You need brackets. So for polyatomic ions that you need multiple of, you need the brackets. With the sulfate, did I need to put a bracket around it? No, because there's only one.
Yeah.
But with the hydroxide, I need to put brackets around it because I have two. If I don't have the brackets around there, you are saying you have two hydrogens and one oxygen. When I put brackets around the whole thing, I'm saying I have two hydroxides. All right? If you wrote, let me grab my little erasable markers now. If you wrote this as your answer, and that was all that you wrote down on the assessment, I cannot pass you on it because you have not identified the precipitate correctly. That's why I want you guys to write the word of the ionic compound as your backup option because I can pass you still on that. Okay? This one is incorrect because when I look at that, that 2 only applies to the hydrogen. It doesn't apply to the whole thing. Shall I erase that little bit? Because it's actually wrong. All right? The main idea that you're thinking about is you're taking the negative, oops, I shouldn't have underlined that much. You're taking the negative and you're swapping it around. So that way you have the new combination of positive and negative. Are we good? Do you guys need another example? Yes? All right, I don't have to do it in this much detail. I can do it a little bit faster. Just trying to put my pens back where they're supposed to be. All right. Do you want another example? I heard yes. Yeah? Okay. No? Your yes or no? All right. If you don't need another example, feel free to go through page 43 and do corrections. Make sure you write down both potential products, identify the precipitate, and do the formulas, and just double check that you have those all correct. If you do need another example, I will do another example with barium chloride and sodium hydroxide. Okay? And I'll do this one a little bit faster because you don't need as much scaffolding. All right. What did I say? Barium chloride?
Yeah, barium chloride and sodium hydroxide.
I'll do this one a little bit faster because you guys already have the foundation. All right, so remember what you are doing. You are taking your anions and you're swapping them around. So with the products in this case, you would have barium hydroxide. This is the second question on that SciPad page. And you would have sodium chloride. Because I was writing and it's not sure what to focus on. That better? Yeah. All right, are you okay with how I just swapped it around real quickly? Because I figured you guys have foundation stuff. All right, so again, we use the solubility rules to check which one's soluble. So I'm looking for stuff that are relating to group 1, because that's what sodium is. I'm looking for anything that could mention chlorides, and I'm looking for chlorides and halides. And I'm looking for stuff that's mentioning hydroxide and barium. So let's look at the barium and the hydroxide. So when I look at that barium and hydroxide, let's look at the hydroxide rule. So all hydroxides are insoluble except group 1 and ammonium. Well, if I look at the periodic table for barium, barium is not in group 1. So that tells me that that hydroxide will be insoluble. So that would be my precipitate. Are we okay with that? All right, the next one I have is sodium chloride. Now, this is just normal table salt. So does normal table salt dissolve in water? Yeah. If I wasn't sure, I see all group 1 compounds are soluble. Sodium's in group 1. I also see that it says Most halides, which this is, are soluble except if you have silver or lead. Sodium is not silver or lead. So that one will be soluble. Are we good?
Yeah.
All right. Next thing I need to do then is my ionic formulas. So if I don't know my charges, let's use the resource sheet. So barium, I see right here, that's my Ba2+. Let's look on my list of anions. For hydroxide, I see it's over there, OH-. So I see that one's 2+ and one's -1. Again, we need to balance to 0. So how am I going to change that? Which one needs to increase? The OH, the hydroxide. How many do I need? 2. So I'd write Ba. Do I need brackets for this guy?
Yeah.
Yes, I do. All right, next one is sodium chloride. So, again, look at the sheet. Sorry. Oh, it's paused. Oh, that's weird. Come on. Catch up. Hello. Do I need to restart? So I'm in 2 places at once. You can see my hand on the document camera, and you can see my hand in real life. We're just going to restart it. There we go. Oopsie. Losing all my papers. There we go. All right. So, trying to get my marker. I haven't done brown in a while. Let's do brown. All right, using my resource sheet, if I forgot the charge of sodium, I can see it on my list, and it's Na+. And then chloride, again, if I forgot the charge, I can look at the sheet here. I see that it is -1. Are those balanced? +1 and -1? Yes, so I just write NaCl. Cool? All right, what else did I want to say? Be mindful that you only need brackets for polyatomic, so when you have multiple atoms in that ion. In this case with sodium, I did have that 2 written down, but I didn't need to put any brackets around it because sodium is a monoatomic ion, meaning 1. Cool? All right. I'll let you guys have some time to work. I'll print off a table of ions. Yeah? I'll quickly run and grab that. So, is go through page 43 and double check your work. Make sure you have the right ions written down, name and formula. Make sure you've identified the precipitate correctly. Cool. Can I give you guys some more instructions? All right, so to-do list. I want you guys to finish that page 43. I want you to double check that work. Don't worry about equations at this point. You're welcome to give it a go, but I will do a whole separate lesson on equations, so I don't want you overloaded. When you are done, I want you to make sure you check off your predictions with me. Check your work with me, and then I want you to have a chance to do a practical and confirm your predictions. So you'll be able to, in a moment, mix some solutions together and see if the precipitate actually forms. So, here are the practical instructions for you guys. Since it is the time of COVID, what we're going to be doing for you guys, since we have so many practicals, is we are going to assign you a pair of goggles, and I wrote Google. Yeah. You can tell how many times I write Google assignment. Get a pair of goggles assigned to you. There we go. Okay. There's nothing on the screen. Okay, now I'm ready. Okay, so, right, phones away. Looking up and listening at me for the next bit of instructions. So, everyone's going to be assigned a goggle. What I'm going to have you guys do when you get assigned a goggle is to write a number on the side. And I have you guys each with their own number based in alphabetical order. We're trying to avoid these goggles getting scratched up. So at the end of the lesson or at the end of the practical, you can put your goggle in your assigned number. This only goes up to 15, so anyone above 15 is going to put theirs in an ice cream box instead. We're trying to make sure they don't get scratched. The reason why I want to assign you guys a pair of goggles is because if I assign you guys a pair of goggles, then I don't need to keep washing them for the next class. So you guys can use these goggles for the duration of basically this assessment and titration as well. So it just helps kind of overcome that barrier. If we weren't in COVID times, we wouldn't worry about washing the goggles, but because it's going so close to your face, it's probably a good idea that we assign you each a goggle. I'm mindful that the goggles do fog up a little bit with the mask, so I do have the medical mask with the wires. If you don't have a medical mask with wires, or if you just want a new mask to try to push the wire down, hopefully it shouldn't fog up too much when you do that. So that's kind of the first thing on the agenda. That one's my copy, so I'll make sure I write a T on there. Then when you guys are doing the practical, there's some things you need to collect. The first thing you guys will need to collect, I should say everything you need to collect is on this left-hand side of the classroom. Alright, so you will need a test tube rack to put some test tubes. You can have as many or as few as you want, because you can wash them out and reuse them. The test tubes are over here as well, and that's basically that setup. Now, I'm giving you quite a bit of solutions. There's actually 9 different solutions there, because they match page 43, because I want you to look at page 43, take the 2 solutions in theory that you're going to be mixing together, and check if this is there or not. Does that make sense so far? Now, since there are so many solutions, you will be taking an ice cream container, and you will take one of each, so that way you have all the solutions available to do the mixing. Make sense so far? All right. So, I want you to get those side pad pages done first. Or not side pad pages, side pad page done first, and then we can move on to the practical. Some other housekeeping stuff is the 2 solutions you are adding together are the ones that are listed on page 43. You just need a few drops into the test tube. Don't squirt, because you're just going to waste reagent. It's just for you to double check your predictions. And then when it comes to cleanup time, gentlemen, when it comes to cleanup time, all you need to worry about is just pour it down the sink, rinse it with a lot of water, rinse the test tube with water, and return it. Now, that sink over there in that corner, I believe is clogged. I see that there's water in there, so don't use that sink, but there's 1, 2, 3, 4 around the sides that you can use. All right? But I don't want you guys starting the practical until you finish that page and you get your goggles aside. I'm guessing you guys are done? Yes. All right, cool. I'll leave that up. Let me pause the recording. All right, cool. Let me recap the lesson, and then we need to do our little wipe down the table shebang. So, to sum up, today we were processing how to do those precipitation reactions, and also how to write the ionic formula. Some of you guys are working ahead to the equations, which is fine, but just be mindful that I will go over them. I don't know if next week is the plan, but we will go over them because it is part of the assessment. So, by the end of today, you should be able to figure out what the 2 ionic products will be when you mix solutions together, and you should be able to figure out if there is a precipitate and which one is that precipitate. So, last thing that we need to do that is wipe down the tables and spray them. So, here are the spray bottles, here are the wipes. You guys for the last period are Tuesday, so close the chairs and close the windows. So spray, wipe down the tables. After the tables are wiped down, then you can put up the chairs, the sequence of events. And then close the windows is the last thing on our agenda.